Welcome back. We have our hypotheses. We have our sample data. We've got our alpha value for significance. So let's forge ahead. We've got a little bit left to do. We've got some test statistics to find and p-values to get based on those test statistics. Now, there's other ways to get p-values as well. I'll make a couple of videos at the end of this series and the next series to kind of just give you alternatives to finding p-values. But this is the method that is tested most commonly in this course by Pearson, WebAssign. So for your sakes, we'll just go ahead and go through the traditional Math 1530 style approach to this, which is test statistics and then p-values. So to get test statistics, use that equation that I gave you at the start of this series, x minus mu divided by sample standard deviation, which is also in turn divided by the square root of the number of samples. So for this first claim, you'll notice I had 600 samples. I had an x bar, or a mean, of 2.57 and a standard deviation of 6.505. So that gives me altogether a t-score, or a t-value, of negative 16.105. And that came about just by plugging in numbers in. I did that by hand. I could have done it on Desmos. I could have done it on Excel. I could have done it on StatCrunch. I could have done it on R. I could have done it on any number of available resources to get those values. The test statistic comes by pretty easily from any kind of computational software. It's just number crunching, and computers love crunching those numbers. So if you want to pause the video and use these claims and these test values, then you can come up with the other two test statistics. So if you're feeling frisky, go ahead and pause the video. Now, go ahead. Anyway, you're all back, and we will now reveal the other two test statistics, 2.01016 or negative 1.661. And these, again, come about by just plugging into that same formula the different values for mu, n, x bar, and s. So I trust your ability to crunch numbers. If those don't agree with what you found, then you might want to revisit what you had there. So all that we're left to deal with before we make our conclusion, we got one more step before we make the conclusion, which is finding the p-value. So the p-value is the area of the critical region, is the probability of getting your sample that you did get out of random chance, assuming that the null hypothesis is true. So the higher values for p-values means you were more likely to get the data you got with random sampling with the null hypothesis being true. So if you want the null hypothesis to be true, which again might be this guy right here, this third claim. We want the null hypothesis to be true because that was our claim. For this one, we want a high p-value because a high p-value means this null hypothesis is probably true. For the other two claims, we might want a p-value to be low because a low p-value means this null hypothesis might not be true, causing us to lean more on the alternate hypothesis, which, hey, is our claim personified. So to get the p-value, what you look for depends on the type of hypothesis you're testing. If you claimed equality, then you'll do a two-tailed test. You'll get both of these regions. Or more specifically, you'll get the one region and double it. For the left tail test, you look what's to the left, because that's what's less than a spot. If you claimed greater than, you'll do a right tail test, because that's what's greater than. And the ways you can do that, probably going to involve technology here. So you can pull up Desmos, you can pull up MathCracker, you can pull up any number of resources, and that will give you your p-values. So I'll